Hello everyone. So today we are solving a question of JEE ADV 20 and 15 from the topic of electrostatics. So let's first read the question. So they're given an infinite long uniform line charge distribution with charge per unit length equal to lambda lies parallel to the y-axis in the plane of yz at z equal to root 3 by 2a, and the magnitude of the flux of the electric field through the rectangular surface ABCD whose center is lying on the origin is equal to lambda L by epsilon naught, and we have to tell the value of N here. So a figure is also given here, but like I don't find it very much comfortable to solve the question. So let's make our own figure here. Uh, so basically, if we assume this is our dimension here, okay, like this. So where is our rod here? If suppose I name this as x-axis, y-axis, and z-axis. So let's read again. So the long uniform charge lies parallel to the y-axis. It means it is parallel to the y-axis at z equal to root 3 by 2a. So if suppose this is the point z equal to root 3 by 2a, so our line charge is like this. Okay, but as it is infinite, so I can extend it also up to infinity. Okay, so this is a long charge. Okay, now where is our that loop ABCD or the surface here? So it is in the xy plane whose center is lying at the origin. So it is something like this. Okay. Let me adjust its center. Yeah. Okay. Perfect. Now, what is the electric flux? It is nothing but E dot dA. Okay. I mean the electric field, which dot product with the area, or the dA can be integrated to the whole area. Okay. So let's suppose here you can see that for this distance is different if I take in this way, and this distance is different. So basically there is not uniform electric field all through the our area here. So what we have to do, we have to take integration. So let's make how the component of integration. Let's suppose at some distance r in the x-axis, we are taking a small portion dr like this. Okay, and let's me clear this. Okay, so in the x-axis, its length is a here. So it's a. Okay, total length is a here. So we can mark this length as a, and in the y its length is l here. So this length is l. Okay. Now if we take a small component dr, as I was telling, so what will be the flux passing through it? So how we will describe here? So first of all, what will be the electric field due to a long charge? It is nothing but lambda by 2 pi epsilon naught times r. Okay, lambda by 2 pi epsilon naught r, where r is the distance from our long straight wire or any rod or kind of thing that. Okay, so what is the r here? So if you can clearly see, we can apply a Pythagoras theorem here. Let me make more clearer here. If suppose this is our rod, this is the sheet here. Okay, so from this point we have to put this here, Pythagoras theorem. So what is the distance there? So it is nothing but, you can see, root 3 by 2 a square plus r square under root. Okay, so what will be electric field here? That will be equal to lambda by 2 pi epsilon naught. What is distance here? It should be equal to r square plus root 3 by 2 a square, that is equal to 3 by 4 times a square. Again, what is area now? We have told that it is equal to a dot dA. So what is dA here? It is nothing but L dot dr. Okay, we are considering it as dr length. Okay, so L dot dr. Okay, now we have to integrate this from where to where? You can see this point is nothing but minus of a by 2, and this point is a by 2, and whole length is a here. So we have to integrate this. Let me write it again. Integration from minus a by 2 to a by 2 lambda by 2 pi epsilon naught into L dot dr by root under r square plus 3 by 4a square. Okay. So if you know the integration of like these all things are constant here. So let's take them out first. So this should be equal to integration of minus a by 2 to a by 2 lambda by 2 pi epsilon naught, and this integration is nothing but root under 1 by, let's say this as a constant, 3 by 4a square plus r square dot dr. Okay, if you know this integration is nothing but root under 1 some constant plus, basically we have to use the this one integration, a square plus x square here. Okay, so what is this integration? It is nothing but like one thing we have always been missing here, that as I told you that flux is nothing but E dot dA, but we are not considering the dot product part here. And what is E dot dA? I should write it like E dot dA is equal to E multiplied with dA into multiplied with cos theta. And we have been ignoring this cos theta every time. So let me write that term all like everywhere. Then only this we can find the perfect answer here. So let's put what cos theta will be. Let me draw a figure to illustrate this. This is our straight line here. Okay, let's suppose this is our straight line. And this was our loop or the surface area. And this is parallel to something y-axis. So at any point like this, see this distance is nothing but root 3 by 2a. And at any point it is making some theta. This theta will be equal here. And the area vector will be like perpendicular to this surface. So every time cos theta will be same as this theta. And what this theta is always constant, which is equal to root 3 by 2a by root under nothing but x square by, r square plus 3 by 4a square. So that's why I have to multiply this everywhere. Let me write everywhere. So here it should be multiplied with root 3 by 2a by root under r square plus 3 by 4a square. Again, if you multiply it here and here, so final integration that I will, let me erase this, all the incorrect ones. So we will get our final integration as like this. Integration of lambda by 2 pi epsilon naught into, there is, I think L should be there, L into root 3 by 2a into, now this is a constant part actually. We will get integration of dr by r square plus 3 by 4a square. Now this is our complete integration from minus a by 2 to a by 2. Okay. Now this is of the form of 1 by a square plus x square. And we know that integration of 1 by a square plus x square is equal to 1 by a tan inverse x by a. Okay. Now putting this here, we will get lambda by 2 pi epsilon naught into root 3 by 2a. If we divide it with 1 by a, 1 by a is here is root 3 by 2. Okay. So if we divide with this root 3 by 2a into tan inverse of r by root 3 by 2a. Okay. Tan inverse of x by a. I think this is correct. Where r varies from minus a by 2 to a by 2. So let's cancel this all and let's put here. So lambda by 2 pi epsilon naught into tan inverse of, if we put initial value of a by 2 here. So a get cancelled, 2 cancel. So tan inverse of 1 by root 3 minus tan inverse of, if we put minus a by 2, so we'll get, I think, minus 1 by root 3. Okay. So we all know that what is the domain of tan inverse? It is nothing but minus pi by 2 to pi by 2. So this comes when tan inverse of 1 by root 3 is, I think, pi by 6. So lambda by 2 pi epsilon naught into 2 times tan inverse of, let's write the answer finally, not tan inverse. 2 times the, see, pi by 6 minus pi by 6. So it should be 2 times the pi by 6, cancelling 2 here. So we get our final answer as lambda by, pi also gets cancelled, lambda by 6 epsilon naught. Okay. Into, I think L should be there. L was not cancelled initially. Yeah. L was as a constant there. Into L. And here also L. So lambda L by 6 epsilon naught. So see whether it is matching to our format. Yes, it is absolutely matching. And we found our value of N is equal to 6 here. Thank you, and sorry for that mistake. Like I missed cos theta there. Thank you.